I really enjoyed the keynote with Sam Aaron's talk on the live coding and music. He's doing the thing this evening at the Speakery, so also looking forward to that. Okay, my name is Alex Thissen. I'm from the Netherlands, a small company, 30 people. We do consulting, and we go to a lot of companies, and we essentially help them move to the cloud. We see a lot of things happening, and we see a lot of things on the Azure platform, and .NET Core is a nice fit with that. So who of you have used .NET Core, are really experienced in that? Okay, not everybody, so a third of the room. We're going to talk about .NET Core dependency injection because it's in there, and it has a lot of nice features. But then again, the dependency injection is not really new. It's been there, there's other frameworks for it, but now in .NET Core you get one for free, and it's all over the place. Do we like that or not? That's sort of the thing that we are going for in the next 50 minutes. This is very opinionated sometimes because people have opinions about design patterns and doing stuff. But you know, the dependency injection, why do you need it at all? Because it makes things a bit more complex. Why do you need it? Well, foremost, people will say it's for unit testing. Because if you have any dependencies, it will make, I'm tripping up the wrong buttons, sorry. If you have any dependencies, it will be hard to make your unit and to test your unit without any of the dependencies. Dependencies being connections to the outside world, file system, network connections. So having dependencies injected, make sure that you can control what your dependencies are. And in dependency, unit testing is very useful. So the other thing is if you do the solid principles by Uncle Bob, one of them is the dependency inversion principle. That's another reason to do dependency injection, because it says that you should invert the dependency. Something that is dependent on something else should not determine what it uses. It should be the other way around. Sometimes they like to call this, don't call us, we'll call you. This will allow you to write a bit of code, have a dependency, not know what the dependency is because it will be controlled from the outside. Dependency injection is a pattern that allows you to stick to this principle and do that well. But once you start doing this, getting control of your dependencies, and you will find boundaries in your system where things can be more loosely coupled. So one of the things that we find with customers is that they have these large systems, and they want to get more control over the various autonomous parts of their application. So the loose coupling is those places where you can actually disconnect from the rest of the system. And that can be many ways. It can be in component terms, and it can be in loose coupling in terms of the individual parts of a distributed system. I found this one. There's a reference to Jason Taylor, who created this diagram, but it's a more general idea of clean architecture, which says that if you start writing your domain logic and then your application logic, and then outside of that you create all of the things that depend on the innermost layers. And once you go into this type of architecture, keeping everything clean, you will see that application knows nothing about how persistence, infrastructure, or presentation is done, but it does know the contract. So the abstraction, that's part of what defines an application, but it's up to someone else to implement the actual abstraction. For example, how do you access a repository? The application would define an iRepository interface, and something else outside would implement it. But it needs to be injected into the application logic. So those are all the areas where you have dependency injection. Related terms are the inversion of control, or IOC container. Some might argue that an inversion of control container, as you usually see it, especially in .NET Core, is not an inversion of control. It doesn't control any flow or logic. It's a dependency injection container. But both terms are valid, and you can use them, and you will find them once you start using this. Okay, to take you through a quick tour. of how this works. Imagine you have a home controller, which is pretty typical for an ASP.NET Core application. The home controller depends on certain things. And like I said, it can define some abstractions. So what you could do is define this iRepository, an abstraction that defines the exact contract of how it knows how it wants to communicate with a repository thing. That's abstract. And this is a boundary. This is where you get your loose coupling. Then, because the home controller doesn't know how to get the actual iRepository implementation, you need something on the outside. That's the container, sometimes called a builder, but there's also a builder pattern. And the builder pattern is a mixed term, so we'll stick with container for this session. And let's assume that floppy disk repository, that is the implementation of the iRepository. It's created somewhere in between, and the container knows how to create this dependency, because it knows that iRepository maps to a floppy disk repository for this particular application. So once it creates an instance of the home controller, it will actually inject it into the created instance of the floppy disk repository will be injected into the home controller. So that's what happens, but it goes a bit deeper, because the floppy disk repository or any of the dependencies might have additional dependencies. And they also have abstractions in most cases and implementations. And this will create a dependency graph. So it starts with the top object that the home controller needs. It will create a dependency, and the dependencies of the dependencies. The logger is a typical one, but it can be any complex graph that you create. And this is how it works. Okay, on to the next thing. This is a short demo for the people that didn't see any ASP.NET Core yet. Usually when you get started with ASP.NET Core, the first thing you'll notice that gets your attention is the startup class. In the startup class, there's, let's get rid of a bit of clutter. This is usually where things related to dependency injection start, although you might not even realize that it's there. We'll talk about this iService collection, but the services is what you need to use to register things into the dependency injection system. And that's used under the covers by ASP.NET Core. So for example, you could do something like, and this is where it's sort of a fluent API and a builder pattern. So you can do a directory browser, for example, and then you can do something like add health checks. And sometimes those things, these add methods, they veer into this this thing underneath. So this is going to do add checks. This is the builder pattern for the health checks. And you can't really chain them together anymore, but if you do something like the services, you can actually go back to adding more stuff. So you can do add HTTP and so on. So this does all these infrastructure things for ASP.NET Core, but underneath the covers, it actually does a lot of registration. So let's run this quickly and hit that breakpoint. Because the services is all the things, all the mappings that we talked about that know how to go from an abstract definition to the actual implementation. And if you look, once you start up, and there's hardly anything here, this is a pretty bare bones application in ASP.NET Core 3.0. You see that there's already 265 of those mappings registered. So there's quite a bit of dependency injection going on. And the next part will be, how does that all work? All right, let's leave that for there. So .NET Core gives you this dependency injection. It's already in your application. You can't get around it. It's there, and it has a certain life cycle. And the first part is that you need to register all of those mappings from the abstract to the specific type, and you would do that with that iService collection. It has a number of methods, the add methods, where you add all the individual mappings. We'll talk about that in a bit. But what we just saw was extension methods. Extension methods like add health checks that make it easier to do all the actual registrations, all the individual mappings, because that's more complex, and it's convenience methods that you will see with all those add. Where do you register? And this is a tricky part. You could do it at component level, but mostly you would do it at the application root, because only the application root knows of all the dependencies inside of the application. So your entry point is the place where you do it, and it's standardized in ASPNET Core, being that startup class. You can do it in other places. You don't have to use the startup class, but it's very convenient. Then you have the next part is you want to use each of those registrations, and that's where the service provider comes in. There's the iService provider, an interface that you can even inject into your system. It will help resolve all of the types. So if you ask it for a certain iRepository, it will know based on the mappings, I will give you an instance of the concrete implementation, like the floppy disk repository. Usually that's done at constructor injection, and this is the only way that you can inject it. There's other dependency injection patterns. For example, you could do method injection or property injection. Those two are not available in .NET Core. But I think you will hardly miss out on them because the constructor is actually a really good place to do it. There are some ASP.NET Core specifics. So in ASP.NET Core, there's other ways of doing it than just by having dependency injected at the constructor level for objects. If you want to get down to this and take control yourself, you can do that with get service of T. You can just ask for a get service of iRepository, and you will be given an object or sometimes an array of objects for all if there's multiple mappings, and you resolve the objects yourself. That's sometimes also referred to as the service locator pattern, because you're taking control, and it's one of the anti-patterns, which I'll name a few at the end of the session, but be careful doing that kind of thing. Okay, so last part is you've used them, now you want to dispose of them, because sometimes you need to get rid of the internals and get rid of that before the garbage collector kicks in. That's where you're in luck, because everything that's being resolved through the dependency injection system is also released by the dependency injection system. It uses the notion of the scope, and at the end of the scope, everything that implements iDisposable will be disposed. And there is a thing with child scopes that we'll talk about, but there is a way to do to get a little bit more detail on that. But normally, everything will be disposed automatically. So this is your lifetime. You will go from registering them to using them and finally disposing them. Well, I briefly mentioned the mappings that you do. So the mappings are done by add or try-add methods. Add will register something. If it's already there, it will register and it becomes a second registration. If you try-add, it will add it only if there is no existing mapping. Be wary of those because, for example, in health checks in ASP.NET Core 2.2, there's a little bug that actually trips over the fact that they use try-add, which is very forgiving. But if you want to really register something, you should use add. That's one way of doing it. So you map in generic terms the service type, which is the interface, to the concrete type. That's your implementation type. If you need more control over how it's constructed, because if you just do type mappings, it will do, instantiate your objects based on the generics. So it's not knowing what is there. We'll just use the constructor that is most suitable. Usually that's the longest because it has all the dependencies for the dependency injection pattern. But you can get more control with an implementation factory, which is a delegate that allows you to define how you construct a particular object, and then you can get more control. Like you saw, you can chain them together in the builder pattern. So this is usually getting into an array of, or a long list of all these add methods. The next thing becomes, okay, so you register them all, you want to use them, how long should they live? There's three options there. The first one is the singleton. Singleton is like the pattern itself. It it will create one instance of your object per DI container. So once you ask for a resolve of a object that is registered as a singleton with its lifetime, it will give you one and the same one for every other time that you ask for it during the lifetime of the container, which is essentially the lifetime of your application. If you start doing that, and if you have a class that's being resolved that way, then make sure that you be wary of any concurrency or threading issues, because you will be using that single object from multiple places in a concurrent system. So, but still, if you have a thread-safe object, that's sometimes a good way to go. Then there's the scoped one. Scope means that there's a longer period that an object lives, but it's not infinite, so not a singleton. And the scope where it comes in really handy is for ASP.NET Core web requests. So for the duration of a request, whenever you ask for an iRepository, or if, for example, take DB context, which is the entity framework unit of work pattern for all the work that you're doing to your database, you can get that object in multiple places, and you will build on the changes that already have been built. During the scope, at the end of the scope, you do something like save changes, and it will commit everything inside of that unit of work that you've built. So that's where scoped comes in. And then the transient is things that are single use, like a match. You strike it, it burns, it's no longer usable. If you have those type of objects, or you just want to make sure that they're clean, then use the transient, because you will get a new object every time. Now, to register those, we already saw that in ASP.NET Core, that's being done in the startup class. The startup class expects a number of things, so it's convention-based. You can actually do more things, which we'll also talk about, but typically it will do this. So in the first part is your constructor. If you use the top part, use startup with the class startup, the bootstrap mechanism will look for the startup, it will construct it, and it will already inject the I configuration and I host environment. Those two can already be injected, and you can examine your hosting environment and the configuration that's been built up so far. So that's the first part. Then secondly, we go to the configure services, which I demoed just a moment ago. So you will use the iService collection to register all of your mappings. And then you can configure them, because sometimes they need to be registered, but also configured a bit to get influence on the objects that will be created. And then thirdly, you will go into the configure, which is more configuring the application as a whole. It's where you do your pipeline for the middleware. And there you will inject by default the iApplication Builder. But after that, you can just inject everything that's already been registered by configure services. So there you can build up this list of abstractions, and everything that is registered in configure services, so known to the system, can be injected and is available there. But in ASP.NET Core, there's plenty more things on how you can actually get at your objects during the resolving. We talked about the constructor injection, but there's also this attribute from services, which you can use in controller methods. And if you just tag a parameter inside of the method with from services, it will inject that dependency into the method once it's being called. So you could do that in your index method or your get method for a web API. You could just say, this method has a I repository. Sometimes that's useful if you don't think it's necessary to inject everything at the constructor level, because only some of those dependencies are used in the individual methods. So you can stick to this from services and inject the appropriate one just at a single thing, because the controller objects are created every time. So if you're injecting like 10 dependencies, but you call one method and it only uses one of those 10 dependencies, and the other 9 are used by other methods, you could optimize here. There's add inject for the views, and I'll show those. There's request services, application services, and you can even have conventions in your middleware to do injection in your constructor of your middleware objects, or in the invoke method. Once it's being called, you can also leverage the dependency injection there. For those digging deeper, I put this tip there that you won't need at the beginning, but this activator utilities has a number of methods where you can activate, like the activator create instance. This activator utility allows you to create instances where you only know part of the constructor method parameters. So you can say, I know the first 2 or 3, but the dependencies, take those from the dependency injection system. So that's a nice one if you want to get more complicated. Okay, next demo. We'll go to ASPNET Core again. Our thing is still running. Let me see. So one of the things I created here is this naive mapping. So I'll show this down for real estate. I have this interface iThing. It has a go method, nothing special. There's actually some bit of code, and the source code is available on GitHub. The link will be shared. But this actually checks if there's if this is a singleton implementation, and this is just to check if there's only one of these created. So otherwise, it will give an invalid operation exception. This something interface is supposed to be used only once. So if you trigger it, it actually has a guard that says, okay, if it's already triggered, it also fires this. So this is just for demo purposes to see the effect of a singleton or a transient registration. And those registrations are up here. So this is where you do something like add singleton. And you do the mapping from iThing to thing, iOnce thing to something. Those are the mappings. I showed you that there was also a try add singleton or something. And you see that IntelliSense doesn't really show it because the try method are extension methods, if I'm correct. Try add transient. No. They are extension methods from the Microsoft extensions, dependency injection extensions namespace. Okay, so they will go there. These will all be injected, and now the thing becomes, how can you get at those individual registrations? So how can I get a thing into my controller? Where at the controller level, you will do something like this. So this is the constructor injection, the most simple form. You just specify 2 parameters, and those things will be injected based on the registrations. And you can use them wherever you see fit. The other thing which I mentioned was the from individual methods, you can use the from services attribute. So this thing, this from services, will also inject a once thing, but it will be a different one because it will be injected again, and making it using the lifetime, which was transient, so a new one. If it was a singleton, it would be the same object again, which doesn't really make sense because you would already have it down here, because typically the injected parameters are stored as fields and you use them throughout your application, your class. Okay, so that's the thing there. In your views, you can do this. So in your view, you can do add inject, which is directive where you say, I want to inject something that is of type iThing, and I want to call it thing. And then later you can just specify it with this expression and just say thing.go, and it will be injected into your view. That's the other thing. And then finally, in your startup class, I told you that you could do a number of additional parameters at the end here. So you can just go on, do the I thing, I something, or all the real stuff that you've been doing. But if you need something more, you can actually get at the application services, which is the iService provider. So the iService provider allows you to get at all of the registrations and do something like get service. And you can do a get service of iThing, which is something to be wary of, because this is the service locator pattern. You're taking control, but there might be situations where you can't actually have it injected and you want to get at a certain object. This is the way how to resolve it by hand. Okay, and then finally, and this is what you might need at some point, there's actually, if you want to go about it, this is like a real web API thing. But if you want to resolve them at any other place based on HTTP context, HTTP context should never be inserted by itself. So if you do like a web API client, like options that you configured, your logger or your logger factory, you can all inject those, but don't inject HTTP context, which is possible, but it's not a recommended practice. You need the HTTP context accessor, and this one will allow you to, at a later point, use this bit of code. So you can say HTTP context request services, which is again the service provider. So the service provider allows you to do the get service or get required service and materialize or resolve the objects that you need. Again, service locator pattern, but there might be situations where this is actually valid to do. Okay. Everyone with me so far? Yeah? Good. Okay. Now we go into the other stuff, because if you already knew this is like a quick bootstrap for those that didn't see this yet. In .NET Core 3.0, and actually already starting in ASPNET Core or .NET Core 2.2, they started to move away from the hosting as using the web host, because they say, okay, if you want to have a host, why should it be a web host specific thing? Because you can host it everywhere, like in a console application, a self-hosted thing. Why should you be dependent on web host? Because it might not be a web scenario. You might be running on an IoT device, which is totally valid. So they came up with a way to move away from the web host and the web host builder to something that now is missing the web part. It's just host, iHost builder. And that allows you to bootstrap an application, host it, still use dependency injection if you want to, but not using all of the things that you would encounter in ASP.NET Core. And even the ASP.NET Core, if you look at the Visual Studio 2019 and the newer project templates, you already see that they're moving away from web host and start using this host, create, default builder, and all the other things that are there. Since it doesn't use ASP.NET Core, you won't see any of the startup classes, because startup is related to ASP.NET Core. So they use different bootstrap mechanisms to configure everything that you would normally do inside of your configure services, your configure, and all the logging and the other configuration that needs to go there is done in a different way. Not drastically different, but you need to know about that. One of the things that is also new in the .NET Core 3.0 is that they have this worker project template. And the worker service allows you to host something that doesn't necessarily go out into HTTP-based traffic, so no ASP.NET Core needed. And it might just listen to a message queue, pick up things, do some work, so actually running in the background and be a background service. That's one of the reasons that they started to go away from ASP.NET Core, not as a requirement, but allowing you to choose when you want the additional payload for HTTP-based hosting. Let's see that. All right, so we'll go to this. And I might show you this because things change around, right? So if you try to find it here, you will actually not find that particular worker template. But if you go to ASP.NET Core, so this is the tricky part. I told you the worker service is not about ASP.NET Core, but you need to pick the ASP.NET Core web application template. If you create it and you get the next dialog, then actually you get to see, if you pick ASP.NET Core 3.0, if it's 2.2, it's not there. 3.0, you get the template for the worker service. That's the thing that I used. And I created this boilerplate thing. And if you go to the worker, this is where the magic happens. This actually is just constructed, and it's constructed with dependency injection, so you can inject stuff there. It has this execute async, which is where you put all your logic, which is repeated in a loop, for example, picking messages from the queue and waiting for them. It has a stopping token that if it's requested from the outside to stop, it will stop, but actually this is an infinite while loop. It will never stop there unless being asked to. You would inject everything that you need, like your logger, other things, dependencies that you might need, and we will get to talk about this iServiceScope factory in a bit. But it needs a thing to work, which is what I did, the thing service. It has an abstraction, and the abstraction is just saying, okay, produce values. And this will just generate the simple values. Now, how do you register this? Because as you can see, there is no startup class. And how do you do the services.add and the mapping of the iThing service? In the new startup procedure, if you don't have a startup class, you could do this: host, create default builder. That's the normal one, and you could use a bunch of methods here that do all the configuration. So the logging, the services, which is here, even the web host. So if you are using a web host, this is the entry point, and it will give you the web host builder again. So if you have extension methods that build on web host builder, then you can use it from this this method here. You can configure your container, which is about custom containers, your app configuration. So everything you need is here in configure methods. And you can just chain them together again as before. And in this case, we registered the mapping with this extension method, because if you just do this extension over iService collection, you can on the inside do everything you need to register something. And in this case, it's a singleton. If you play nice, you return an iService collection, because then the next line can be again .add and something that you need to add with other extension methods. So this allows you to encapsulate your logic into this nice simple method, just like .NET Core itself is also built. And this is where it happens: add hosted service. That's for your background service. And this will inject this worker. So no abstraction, just a concrete type, and it will create an instance of that and insert it. But while creating it, it will also create all of those dependencies and inject those again. That's the object graph, dependency graph that we talked about in the beginning. Okay, so with this, well, the output should be fairly, if it runs, it should be fairly simple. It will just start working and it would generate all of those values every now and again. This is a background thing. You can run this nicely from a container in a cluster, and this will be part of your microservices landscape, because this will be able to do the background things. This is not a web API, but you'll need those. Okay. Then, I'll be brief on this one. If you start digging, or if you want to peel a few of the layers off, each of those add methods, or the try-add methods, will do the implementation to, so the abstraction to the implementation mapping, or use an implementation factory. That's all encapsulated in an object called service descriptor. And there's factory methods that allow you to create the mappings and then just register those mappings straight off as you define them here. I mentioned that it's we have all the scopes in ASPNET Core. That's being taken care of, because the scope of the controller lifetime for an individual method call is already a nice per request lifetime scope. But there are ways or places where you need to get control of a scope yourself. And I'll show that in a bit in the generic host that we saw a moment ago. Because the service scope factory allows you to create scopes, and within those scopes you can resolve your own dependencies, because you want them to be disposed at a certain point, and you want them to be disposed, but you don't have something like ASPNET Core. This is very important, because this, for example, when we did an implementation, this tripped us up, because let me show you straight away. Because this thing, this worker, as you saw here, it does an add hosted service. It adds it as a singleton. So if it's a singleton and you want to do some work, well, in this worker inside this loop, this worker service is only created once. So all of the things that you would inject here would only be created once. That doesn't give you like a new repository that's all clean and transient. So that's sort of a problem. Well, you might say, that's not a problem. I will inject iService provider. And that works. And this is where you get production bugs. Because if you do the iService provider and you start resolving them, they are actually living in this everlasting scope of the application. So none of those objects will get disposed. Even though your method neatly runs out and you do a get new one, you will actually get more and more objects being added, so you have a growing memory. So you'll run out of memory at some point, get unstable clusters, and bad things happen. So the right way to do this is you would create this iService scope factory. And the iService scope factory allows you to create a scope like so. You put it inside a using statement for the disposable pattern. And inside this is where you're allowed to get to the service provider and actually do it yourself, resolve it. Because this is where you say, okay, now I want to resolve something, and you can't do this from the outside. But once you start resolving this iThing service, it will also build a dependency graph again. So all the goodness happens, and you can just call whatever you do with the scoped object. And once it runs outside of this, because it's a scope in itself, it will neatly dispose. So no memory leaks. Remember this one. It will save you time and some nasty debugging. Because even if you have this is what I mentioned, the bottom line, even if you have other transient objects, you register them as transient, but every transient that's injected into a singleton becomes singleton by default, because the singleton is only created once. There are occasions that it actually says you're not allowed to do that. That's the validation. Will pass as well. Okay. Does it sound good so far? Do we like what we see so far? Because that's what the session is about. Thumbs up? No, not decided yet. Because, well, you might say, oh, but it's nice that I get one from .NET Core, but I know one of these. And there's more, but these are fairly familiar ones. And they're much better because they can do other things. And you might be right. What I found, but this is personal opinion, is that ASPNET Core has some missing things, but I didn't really miss it yet. But if you want, you can just say, okay, I want to use my favorite thing because it's part of our agreement. Every application uses, for example, AutoFac or Ninject, and I want to use that as well. Well, some of the outer layers like iService collection will be available and required if you do .NET Core applications. But the underlying container and all the plumbing and the registering of stuff can be done with your favorite dependency injection system. So it's actually where you can plug it in. On the outside, it seems fairly the same. And every place where it's being used with the patterns, you don't actually see the difference. And there's two ways to plug it in. First one is the new one is using iService Provider Factory, because your service provider is your dependency injection framework. It provides things, so that's the container. That's why you use this factory that creates the service provider, and you configure your container, which is where you register all of the things. The other option that works in 2.2 and previous is if you go into configure services, you should change the signature and return an iService provider. And if you do that, you can actually create your service provider from your framework, and it will be that one that's being used throughout the application lifetime. I'll show both of those. So in this generic host, in the startup, that's the program CS, not the startup class. If you want to do a custom host builder, then you would do something like an use service provider factory, and you would create this other type from your framework. So this would be something like Ninject or AutoFac or Light Inject, And then after that, you do configure container. So you will get a Lambda expression where you have your container, which is of type whatever you did with the service provider factory, and you can start registering stuff. Now for the demo purposes, I created this sample container. So if any of you ever want to do that, this is how it might get started. It usually is, if you have the container builder, it needs all of those services that were registered previously, and then it will start to build the container. And then later on, during the build phase, it will actually return the provider that is able to resolve all of those types. So this is the plumbing, and wiring it in is, as we saw here, these 2 lines of code, including the configuring, where you get the chance to register everything inside the container. So you need to configure services before or after, because this will be called at the right time. But this will allow you to do the things like we did before, so you don't really see your container changing underneath. This will stay the same. That is that. If you decide to build it, you might run into this. Microsoft has created this extensions dependency injection specification, because if you build such a service provider for .NET Core, so to be able to fit it in, it has all these specification tests, and you could simply, if you inherit from that with your implementation, if you run all of those tests, you can see if all of the tests that, if they turn green, you did a complete implementation of what Microsoft will be calling and what it expects. In this case, if you look at the sample later on, you will see that underneath the covers, I'm actually using the default service provider factory, which is the one you get by default. So this is just a tiny wrapper around it, but this would be different for your favorite dependency injection framework. All right. The other way to do it, because this is more the style for .NET Core 3.0, the other way to do it is, for example, if you have AutoFac. AutoFac works with modules. So inside a module, you would do the registering. It's kind of the same thing, but this is more of a Fluent API where it says register this type from the mapping of iThing. This is AutoFac. If you know AutoFac, you'll love this because you're like, yeah, this is where I'm at home. So what does it take to wire that in? And not all of them have implemented, you know, the specification like we just saw. So you need to do the other method. And the other method uses the configure startup. And in configure startup, this is no longer a void return type. It's iService provider. And you go through the regular stuff. You do add MVC and you do all your things. And then after everything is done, usually at that point, you start building your AutoFac container. And this is the essential part. You populate it with everything that we registered from the iService collection. And then finally, you return the AutoFac service provider based on the container. So then you expose it to the outside. And if .NET Core wants to resolve things, it will use iService provider, but that will call the underlying registrations from the module right here. And that's actually all it takes. So this application will use AutoFac for resolving types. Yeah. Okay. Some other things that will come in very conveniently, because we've now seen how to register them, how to resolve them, how to do it with your unit or the dependency injection framework. But then it becomes more complicated, because you will notice that there's a difference between registering types for development or staging purposes, like those environments or testing environments, versus the production environment, because you might need different things. You might need some mocks to stub out things on the test environment. This is not really well known. It's documented well if you can find it, but you can use other startup conventions. Normally, it will just do. It will look for the startup class. So it will find a class and it will start using it. But there is a way, and it's listed at the bottom. If you that's the new stuff where you need the use startup in the configure web host. If you do use startup and you give it an assembly name instead of the generic type of startup, it will do convention-based startup. And it will still do the same thing. So it looks for configure services, configure, but more intelligently. So first of all, it will see if there's a class that's called startup, your environment name. So startup production, startup staging. If it finds it, it will use all of the methods, configure services, configure, inside of that class. If it only finds a startup class, it will use that, but it will start looking for configure production services and configure production. It will look for method names that also have the environment name in it. This allows you to get rid of all the if statements inside of your startup, like your configure or configure services, where you say if the environment is development, then do this. If it's production, do this. Now you can just split them out over individual methods or individual startup classes. We talked about, and I will show this in a demo in a bit. We talked about the validation of about scopes and how you should be careful doing certain things. For example, injecting transient things into a singleton is not considered a good practice. You can still do it with the get service yourself, but it's dangerous. So Microsoft actually builds in this validation of scopes, that you don't do stuff that's not allowed. You can't inject stuff with a bigger scope into a smaller scope, but not the other way around. By default, it only does it for development environment. And this might also trip you up, that if you do that, and it might work on the circumstances for development, but you don't get the checks anymore as soon as you switch to production environments. So it can result to the earlier mentioned memory leaks, things don't behave as you would expect them. So all of those rules, I fleshed them out from the source code, that's what's being checked for, except for open generics. And this is what you would do. So in the startup, again, new style, you would say, if you would use the default service provider, because the Microsoft one does the validation stuff, you can say, I want to validate my scopes. And by default, the Boolean is set to, is it your development environment? So if you've set that in the startup of your project, if you say this, the ASPNET environment is called development, then it will do the validation of scopes. You could put this to a true, so it's regardless of environment. It will incur some overhead, but it's very safe, or just do proper testing in all environments. The other option is validate on build. That will actually do it once the container is being built based on all the service registrations. You can also do it there, but you will find that this is only in .NET Core 3.0. So in .NET Core 2.2, that property validate on build does not exist yet. So let's see if we can make that work. So we'll go here into this one. I'll set it as startup, and I'll go to the properties. Because this is where you determine, let me see if I can, this is where you would go and specify, this is where you would specify your environment name. So this can be development, staging, production, or anything else, but development, staging, production are well-known values. Normally it would just use this startup, nothing would change. But if you go into your startup here and change this line, use startup with the type, to this use startup, and then go find the assembly name, and you need to have the short name. You find examples on internet in blogs that say full name, but that will not work if you run inside of a container. So take the simple name, just the name of the assembly, not the fully public key token, everything strong name. What I did here is I created this startup production class, and just by post-pending it with the environment name, this will get picked now if we change this to production. So the application will not work anymore, but if all goes well, this would actually trigger the use of the methods inside of that startup production class. Let's see. So as you can see, startup production is now being called. We hit the breakpoint, and then you can do other configure services inside of these methods, and they will be called. But you could also not use a startup production, and in here you could just say something like staging services, and that would make sure this only gets called for the staging environment if it's defined, or production, or development, or whatever you think of. That's that one. Or the other one. Let me see. I believe that is, let me check. So in this class, we're running out of time. We have the validate on build. If I register stuff in the startup, and I do this, and then add demos. Add demos is again one with a bigger one. It has this recursive something, and recursive something is actually not a smart design thing because it's an implementation of once thing, but it requires a once thing to be injected. So we get this infinite loop. If you would run this with the validation on, and run this now, it would validate this on build. So during startup, if all goes well, we should actually hit a, so this is where everything is configured. Now it does the build, and then you get this thing where it says a circular dependency was detected. And it actually helps you find those errors because it validates on build before your application is running. Okay, finishing the last bits. If you start using this or already using this, stay away from the service locator pattern because it's dangerous, but you can do it from the create scope. We saw that. We talked about the HTTP context accessor. In general, stay away from complex lifetime graphs where you have a mixture of lifetimes. Not really well. And then this is maybe for afterwards, during discussion after the session. Do you like it or not? And some might say there's too much abstractions. You're doing conforming containers, so actually .NET Core brings it back to only the basics, which you miss out on all the other stuff, like auto discovery, which isn't there, like the interceptors. So that's where you're missing out. It's easy to use some of the anti-patterns that Newman wrote about. That's for discussion. So with this, I hope you have a good impression of what is there in .NET Core dependency injection. You'll find it throughout .NET Core. If you want, you can replace it, but seriously, think about whether you should just and make a small